Today I'm going to show you transformations of a sine function. We have the equation in the form of y equals to a sine kx minus t plus t. So the first transformation I'm going to use is for a. A is the vertical stretch or compression by a factor of a. Vertical stretch or compression by a factor of a. When the value of a is less than 0, means it's negative, then we have vertical reflection. And then for the amplitude, we have the absolute value of a. The second transformation I'm going to apply is for k. K is the horizontal stretch or compression by a factor of 1 over k. And when the value of k is less than 0, which is negative, then we have the horizontal reflection. And in order to find out the period, we have the equation, which is equal to 360 degrees over the absolute value of k. Now, the third transformation, we have it for d, which is a phase shift. When d is greater than 0, means all positive value, then we can shift to the right. When the d value is less than 0, which means negative, then it can shift, the graph can shift to the left. And the last transformation is the value of c, which is the vertical shift. When c is greater than 0, means positive values, it can shift up or translate up. When the value of c is less than 0, then it can shift or translate down. And from here, you can tell the value of a and the value of c belongs to the value of y. As you can see, it's a vertical shift for c, and for a, it is vertical stretch or compression. And the values of k and d belongs to x. That's why d is left or right, and k is horizontal stretch or compress. Saying that, I'm going to show you one example by using these transformations. So let's just write one example here. We have an example which is for the function y equals to 2 sine 3 theta plus 30 degrees minus 1, we're going to state the transformations. So the first transformation I'm going to state is the amplitude, which is the value of a. So the value of a is 2. It's positive, so we don't have to worry about the absolute value here. In order to find the period, we can do 360 divided by the absolute value of k, which I can write here. Period 360 degrees over the absolute value of k, and the value of k, we have it here, is 3. So I can do 360 degrees divide by the absolute value of k, which is 3 again. When I divide 360 by 3, I get 120 degrees. Now I can find the phase shift. Phase shift is the value of d. In this case, the d value is negative 30 degrees. We always take the opposite sign. If it's positive, we're going to take negative. And I can write here shift to the left 30 degrees or shift left 30. Or translate 30 degrees to the left. And then we have the vertical shift. Which is the value of c. In this case, the value of c, which is outside, it's negative 1. So I can write that equals to negative 1. And I can say shift 1 unit down, or translate 1 unit down. Shift 1 unit down. Then we have maximum and minimum value. We can say the maximum is equal to the value of c plus the amplitude, which is absolute value of a. C, we have it here is negative 1, and the amplitude, I have it as positive 2. Therefore, it is 1 unit. Then we have the minimum value, which I can say value of c minus the amplitude, which is absolute value of a. C is negative 1, and then we have a negative sign in the formula. Absolute value of a is again 2. Therefore, the minimum value is negative 3 units. That's how we can write the transformation of a sine function when the equation is given. We have the amplitude, period, phase shift, vertical shift, maximum value, and the minimum value.